Welcome to The Explainer. Today, we're diving into a really cool paradox from the world of computer science. Get this. What if you could add a powerful new feature to a programming language that lets it do absolutely nothing new? I know, it sounds totally pointless, right? But as you're about to see, sometimes the biggest advantage isn't about what you can say, but how you say it.
So here's our game plan for unraveling this thing. First, we're going to lay out the paradox itself. Then we'll uncover the secret weapon of looking backward, something researchers literally call the glory of the past. From there, we'll see how this one simple idea makes it way easier to check for bugs and even build complex systems from scratch. And finally, we'll see why, in the world of code, being brief is a real superpower.
All right, let's jump right in with section 1, the logic-power paradox. And this is where things start to feel a little counterintuitive. We're talking about formal logic, basically the super precise language we have to use to tell computers exactly what we want them to do, with zero ambiguity. Now, at the heart of all this is a language called Linear Temporal Logic, or LTL for short. Just think of it as a way to talk about time, but with a catch. You can only talk about the future. You can make statements like, eventually this signal will turn on, or the system will keep trying to connect until it gets a response. It's all about what's coming up next. Okay, so what if we want to make this language a little more powerful? A pretty logical next step would be to add the ability to talk about the past, right? We can add operators like since or previous. This lets us say things like, the alarm should only go off if a window is open since the system was armed. This new beefed-up logic is called LTL plus past. And boom, here it is. This is the core of the paradox. It's been proven that, from a purely theoretical standpoint, adding these past operators doesn't actually let you say anything new. Anything you can express using the past tense can also be expressed using only the future tense. It just might take a formula that is absolutely mind-numbingly long and complicated to write. So that really is the million-dollar question, isn't it? If we go to all the trouble of adding these new features to talk about the past, but the language's fundamental power doesn't increase one bit, then why on earth would we bother? What's the real advantage here? Well, that's exactly what we're going to unpack right now. The answer isn't about the what, it's about the how. It's time to uncover the incredible, hidden advantage of being able to look backward. The solution to our whole paradox comes down to one single elegant idea: succinctness. It's not about what's possible to say, it's about how efficiently and clearly you can say it. It's the difference between some long, rambling, confusing explanation and the statement that's simple, direct, and gets right to the point. This analogy just nails it. Imagine you're giving someone directions. With only future tense LTL, you have to kind of carry information forward in your head. It's like saying, okay, keep going straight. Now, remember that cafe you passed 4 blocks ago? You need to keep that in mind because in one more block, you're going to turn left because of that cafe. It's just so clumsy. But with LTL plus past, you can just say, see that cafe you just passed? Take the next left. Same result, but the instruction is 1,000 times clearer. And we're not just talking about a small improvement here. The difference in the length of these formulas can be exponential. That means a simple 2-line idea using the past could blow up into a formula that's thousands or even millions of lines long without it. And that, as you can imagine, has huge real-world consequences.
And this whole concept has been around for a while. It was laid out beautifully in a classic 1985 paper, and they gave it the perfect title, The Glory of the Past. The researchers, Lichtenstein, Pnuley, and Zuck, were the ones who first figured out that while the past didn't add more theoretical power, its true glory was in making logic practical, readable, and useful for humans.
Okay, so let's see where the rubber meets the road. How does this idea of succinctness actually make life better when we're building and testing complex software? Let's talk about a process called verification.
A huge application for this is something called bounded model checking, or BMC. You can think of it like an incredibly thorough, automated bug hunter. You give it your system's design and a list of rules it must follow, and the checker just brutally tries every possible scenario to see if it can break a rule. When we use LTL plus past, our rulebook is so much shorter and clearer, which helps that bug hunter do its job way, way faster. So the bottom line is this. Using the past tense just makes the problem that we're asking the computer to solve much, much smaller and simpler. Instead of this messy puzzle that grows exponentially harder, it becomes a much more manageable linear problem. And in computer science, turning an exponential problem into a linear one is a massive win. It makes the whole bug checking process faster and way more efficient. And this benefit isn't just for checking models. It also helps out with something called satisfiability checking, which is basically just asking a computer, hey, is there any possible way for this complicated logical statement to be true? In fact, a tool called Black was specifically updated to take advantage of these pass operators.
And you can see how the tool tackles this. It has two options. It can do it the hard way by taking our nice, clean past tense formula and painstakingly translating it into a giant, ugly, future-only one. Or it can use its new, upgraded logic to understand the past tense instructions directly. You can guess which one is the smarter and faster approach.
Okay, so we've seen how LTL plus past makes it easier to check if a system we've already built is correct. But what about building this system in the first place? This is where synthesis comes in, the idea of automatically generating code or hardware just from a high-level description of what it's supposed to do.
For synthesis, being concise is an absolute game changer. It's especially vital for what we call reactive systems. Think flight control software or a network router, things that have to constantly react to what's happening around them. LTL plus past lets engineers write really clear assumption/guarantee rules. Things like, assuming the sensor input is always valid, I guarantee the output will stay within these safe limits. This allows you to design systems in a much more modular way.
Now, to make this even more practical, researchers have created specialized subsets of LTL plus past, kind of like a custom-built toolkit for a specific job. And one of the most important ones is a version called LTLEBR plus P, which is perfectly tailored for the job of automatically building these reactive systems.
So what makes this special toolkit so great? Well, two big things. First, it's really good at defining safety properties. These are basically rules about bad things that should never, ever be allowed to happen. Like, the elevator doors must never open while the car is moving. Second, it comes with a super efficient algorithm that can take those rules and automatically build a system that is guaranteed to follow them.
And here, my friends, is the final, brilliant twist that brings this whole story full circle. Remember how this all started with the paradox that adding the past adds no new expressive power? Well, for this specific, incredibly practical job of building safe systems, that turns out to be completely wrong. This quote says it all. If you take the past operators out of this special toolkit, it actually becomes weaker. You literally can't express all the safety rules you need to anymore. So, in this context, the past isn't just a nice to have, it's absolutely essential. Which brings us to our final takeaway. After this whole journey through the past, present, and future of logic, what's the big lesson? Why is being concise, being succinct, so incredibly important? Here's the real story. Theoretical power isn't everything. It's not the only thing that matters. The ability to express a complex idea simply and clearly is its own kind of power, a much more practical kind. That exponential succinctness is a total game changer. It means we can write rules that actual humans can read and understand, and it lets us create algorithms that are fast enough to solve real-world problems that would otherwise be completely out of reach. In the end, simplicity and clarity make the impossible possible. And that leaves us with one final thought. This principle, that making something simpler, more concise, more natural, can actually unlock huge amounts of practical power. That idea doesn't just apply to formal logic. So think about it. Where else in technology, or even in design, have you seen this happen? Where does making something simpler actually end up making it more powerful?